Hello everyone, it's Wilson here. From the request of my students, I am going to do this integral. So as you can see, this is a rational function, so we are going to use partial fraction decomposition to decompose this function, and then we are going to do the integration after. Okay, so as you can see, this is an improper fraction because we have the degree in the numerator is 5, right? As you can see, this is a 5th degree polynomial, and then for the degree in the denominator, that's 4. So because the degree at the top is greater than the degree at the bottom, so we would be using the long division first to simplify this. Okay, so let's just get started. First, we set up the long division house, right? Then we are going to just put that here. And then I can just put the house right here. I think this should be curl, right? So let's just draw it like that. Okay, so we are going to get x to the 5th minus x to the 4th minus 12x cubed minus 60x squared plus 17x plus 13. Okay, and then we are going to put down this denominator here, which is the divisor, right? So we are going to be getting x to the 4th and then plus 4x cubed and then plus 13x squared. And then now we should be putting in the placeholders, which would be 0x and then plus 0. Okay, so now we can start doing the long division. So let's count how many terms that we have for the divisor, including the placeholders. 1, 2, 3, 4, 5, right? So we are going to do 1, 2, 3, 4, 5, and then you are going to start putting the answer on top of the 17x. Okay, so something times x to the 4th will give us x to the 5th. That must be x. So we just put the x here. And then so we get x times x to the 4th. We get x to the 5th. And then plus 4x to the 4th. And then plus 13x squared. No, actually x cubed. And then plus 0x plus 0. X squared. Yeah, that one is 0x squared and then 0x. Even though it's still 0, but I still just want to line up the variables. Okay, so we are going to do the subtraction here with the long division. And then remember, this is a subtraction. So we have negative minus 4, right? So we are going to get negative 1 minus 4. Then that's negative 5x to the 4th. And then continue. So negative 12 minus 13. So we get negative 25 x cubed. And then negative 60, well, that's subtracting the 0. So you just get negative 60x squared. And then 17, right? So 17x. Now we can bring down the 13. So we have plus 13 here. Okay, now what do we get here? We are going to figure out expression here that when you multiply by x to the 4th, we get negative 5x to the 4th. So we can have minus 5 right here. Okay, so minus 5. Then we are going to be getting what? Take the minus 5 and then multiply every term that we have in the divisor and then put them here. So we are going to be getting negative 5x to the 4th minus 20x cubed and then minus 65x squared and then plus 0x and then plus 0. I know that there is a minus sign right here, but for the zeros, it doesn't really matter. So just leave them. Okay, so let's continue with the subtraction. Okay, so what do we get here? Negative 25 minus negative 20, so plus 20. So we are going to get negative 5x cubed. Okay, continue. So negative 60 plus 65, so you get plus 5x squared. Okay, so 17x, this one is easy. And then 13. So now we get the remainder here, right? So now that means we can rewrite this original integral, right? We can actually just give it a name. We can actually give this integral a name. So we can call this, just give it a name and call this one W, right? So W stands for Wilson. So let's just use W. Okay, so now W is equal to what? Is equal to the integral of, okay, so the quotient first, which is x minus 5, right? So you get x minus 5 right here. And then plus, okay, next, what do we put here? We are going to put the remainder over the divisor. Okay, so we are going to be getting negative 5x cubed minus 5x squared plus 17x plus 13. And then all over what? So all over the divisor, which is just copying the divisor right here. So x to the fourth plus 4x cubed, and then plus 13x squared. Now we don't really need to put the placeholders in there. Okay, and actually I should just erase this closing parentheses right here. It should end right here. So now you have the whole integral turn into this one. Okay, now as you can see, this is actually easy to integrate. We can integrate that directly, right? But this one we still cannot integrate directly. So what do? We can decompose this one by using partial fraction decomposition. Okay, so we are doing what? So decompose this one. Okay, so this is the one that we want to decompose right here. Okay, so now what do we do next? Let's look at this. We probably need to do some work right here. Okay, so what can we do? Let's look at the denominator first. We're getting the denominator that x to the fourth plus 4x cubed plus the 13x squared. We can try to factor this, and actually you can see that there is a greatest common factor of x squared, so we can factor out the x squared. So that if we factor out the x squared, we are going to get x squared plus 4x plus 13. Okay, so we have a repeated, right? This is repeated factor for the x. So let's just do the labeling right here. This is x is it's a linear factor repeated, right? This is a repeated linear factor with the power of 2. Now, what about this one? This one you can either just try to factor it, or you can just use the discriminant, right, from the quadratic formula to determine whether it can be reduced to 2 linear factors um, over the set of real numbers. And it turns out that we cannot, right? But we can actually still just use that to do a quick check. So how do we check? We can do the discriminant b squared minus 4ac, right? So you can see that the b is actually the 4, right? The coefficient of the linear term. So you get 4 squared minus the 4, and then the a is what? 1, right? That's the coefficient. And then the c is 13. So you can get 13 right here. And then so you are going to be getting 16 minus, that's what, 52, right? And we actually don't care what that is equal to, but you know that it's going to be less than 0. So this is actually what irreducible over the set of real numbers. Okay, so we are just going to leave it like this. Now let's write down the form of the decomposition, right? So let's go down. And so now how do we write the that decomposition right here? It's going to be this. So let's take the numerator here, and well, let's just copy the whole fraction. So we have negative 5x cubed plus 5x squared plus 17x plus 13. Okay, keep going. Then we have x to the fourth plus 4x cubed, and then plus 13x squared. Okay, so now the form of the decomposition would be a over x, okay, and then plus b over x squared. Why do we get an x squared here? Because remember that we say that this x squared right here, x is linear, and then it's repeated linear factor. So we start from the first power, and then we go all the way to whatever power that you see right here. And then the next one, because this one is an irreducible quadratic, so we are going to be putting cx plus d over that x squared plus 4x plus 13. Okay, so this is the decomposition, right? This is the form. And now we need to figure out the ABCD. And how do we do that? First, we need to write down the LCD right here. So you know that the LCD is going to be x squared and then x squared plus 4x plus 13. This is basically just that same denominator that we had originally. Okay, so we are going to multiply this equation by the LCD every term, every fraction, right, by the LCD. Then what happens is that when you multiply this fraction by the LCD, the denominator will cancel with the LCD, so you're left with just the numerator. So that would give you negative 5x cubed plus 5x squared. Okay, so we just get that numerator. And then now what? So now the a, right? Now when you take this first fraction right here, multiply by the LCD, the x will get canceled with one of the copies, right? You're still left with another x right here. So let's just put that here. And then also this factor will stay because it doesn't get canceled, right? So just leave it, just copy. And then plus b. Okay, so when you multiply this fraction with this one, the x squared will get canceled completely. So you're left with the irreducible quadratic. Okay. And then lastly, we have the cx plus d. Don't forget the parentheses. Okay, so make sure that you keep the parentheses right here. This quadratic expression will get canceled. So you're just left with the x squared. Oh, actually, I gotta use the different color for this one, right? Okay, so now that's the equation that will allow us to find the ABCDs. And you may say, how do we do that? First, let me just start this equation right here. So this is the equation that's really the important one. Okay. So now, what do we do? We can actually try substituting a convenient x value to the whole equation, and then hopefully that will allow us to find the value for one of the coefficients, right? So if we plug in 0, then you can see that this term is going to disappear, right? 0 times anything. And then also when you plug the 0 here, 0 times anything is going to be 0, right? So this term is going to disappear. This term is also going to disappear. So now we are left with just this term, right? And then all those terms with the x will disappear when you plug in the 0. So actually that's really convenient. So let x be equal to 0. Then what happens? Now the left hand side of the equation will just give you the 13. So you get the 13 here. That's gone. This one will stay, right? So you get the b. And then now those terms will disappear. You are left with the 13. So b times 13. And then, yes, so this term will also disappear. So now you only have all this stuff, right? So what is b equal to? It becomes obvious that b is really just equal to 1. So we got b is 1. Okay, now what's next? Well, you can plug the b back in here, right? And then the next step is to actually just, in this star equation, we multiply everything out, right? So the star equation will actually give you this. Yeah, so let's just multiply everything out, right? So on the left side, we just copy. So we have multiply everything out, and we are going to be getting ax cubed plus 4ax squared plus 13ax plus, now the b is 1, right? So just copy, just put the 1 in there, and then you're just going to get x squared plus 4x plus 13 plus, okay, so this one distributes, so cx cubed plus dx squared. Okay, so now you get an equation that looks like this. Let's combine like terms. So that's what we want to do next. So this one and then the x cubed. Okay, and then the other one is this one, the quadratic terms, right? So quadratic terms, also this one. And then last one, the other one, right? The other one is this one here, the linear term. Yeah, also the linear term. We actually don't need to worry about the constant term because the constant terms will match on both sides, right? So we don't need to worry about that. So now let's continue. Okay, so let's put the terms together first. Then we are going to be getting negative 5x cubed plus 5x squared plus 17x plus 13 is equal to, okay, so now if we're putting them together, we get a, the green ones, right? A plus c, right? A plus c. X cubed. And then the next one, the purple. So we get what? We get 4a squared, 4a, right? 4a, no square. Just 4a and then plus 1, right? Because we're just adding the coefficient. And then plus d. And then now the blue terms, the linear terms, we are going to be getting plus 13a plus 4. And then plus 13. Yeah, see that this problem looks so colorful. It's so beautiful, right? Okay, let's continue here. So we can match, because we're saying that the left side is equal to the right side. They are both polynomials. So that means we can match their coefficients because the x cubed term must have the same coefficient as the x cubed term on the other side. Okay, so we are going to set up a system of equations right now. In this case, we can set it up like this. We have a plus c, right? So a plus c is equal to negative 5 because that coefficient of x cubed must be the same thing as the coefficient of this x cubed, right? And then the 4a plus 1. Okay, so just keep doing the matching. 4a plus 1 plus d is equal to what? 5. And then the next one is 13a plus 4. So we have the 13a plus 4 is equal to, well, the 17. Well, the 13, yeah, the 13 will match, right? So we don't need to worry about it anymore. So now what do we get here? We have 3 equations. And then how do we solve the those ones? As you can see, this third equation right here will already give you the answer. So you can just do the third equation. You get 13a is equal to, now subtracting 4 from both sides, you get 13. So you can see that a is actually equal to 1. Now, once you figure out the a, you can plug it back into the first one and the second one and figure out the answers for them, right? So you can plug it back into the 2. Then you're going to get 4 plus 1 plus d is equal to 5. And so that gives you that d is equal to 0, okay? Because that's already 5. Subtract 5 from both sides, you get d equals 0. Now, the last one is going to be what? 1 plus c is equal to negative 5. So c is equal to negative 6. Is that okay? So we got the ABCDs. The B is from here, and then the ACD are here. And so all we need to do next is to do what? So we are going to now go back to the original integral, right? So we are just going to say that W, okay, so what happens? W is going to be, now don't forget that there was still the x minus 5 dx right here. Where did this come from? If you go back up, you can see that we do have the x minus 5 right here. Now, the other partial fractions would be those ones because we decompose this one, right? So instead of writing this one, we are going to write a over x, b over x squared, and then cx plus d over that quadratic expression, okay? So we are going to get plus So a is 1, so you're just going to get 1 over x. And then plus integral of the b is also 1, so you get 1 over x squared. And then plus, now the last one, good thing is that d is 0, right? So we have negative 6x. And then that expression. So that expression is what? I don't even remember. So it will be x squared plus 4x plus 13. Okay. So we get x squared plus 4x plus 13. And then the dx. Now, all we need to do is to integrate those 4 integrals right here. And then we get a final answer. Okay, so let's just label them right now. Let's just label them. We have the first one right here. This is the second one. This is the third one. This is the fourth one. Okay. Let me box them so that they look better. Yeah, so now we just need to do each one. I can do those shorter ones because you can see that there are shorter ones. This one is the balls here, right? This is the final boss that we need to integrate, but those ones are easy. So I'm just going to do it on the side right here. So the first one, okay. What do we get here? So the integral of x minus 5 dx is actually just equal to 1 over 2x squared minus 5x. There was also the constant integration, but I'm just going to omit that. I can actually just put plus C1 or C2 or C3 and so on, right? But I would just put down a antiderivative for the x minus 5. Okay, next one. Next one, also easy. Integral of 1 over x, which is just what? Simply the ln of absolute value of x. Next one. Next one is going to be 1 over x squared dx. This one you can rewrite it as x to the minus 2 dx, which would give us, what is that? That's going to be x to the minus 1, negative 1, right? Which is just negative 1 over x. Yeah, so we got those 3 really easily. Now the fourth one, I'm going to need a lot of space, right? So let's look at this fourth one right here. Okay. Now this fourth one. This fourth one here. Then you may say, how do we integrate this one? This one, as you can see, we get a quadratic expression at the bottom, but we cannot really decompose this. I mean, we cannot really factor this into a product of 2 linear factors unless we work with complex numbers, which we're not going to be using right now. So we can try completing the square. Okay, excuse me. And then so we complete the square, and then what happened is that we are going to do the trig sum. Okay, so as you can see how big this problem is. So now let's complete the square. When you complete the square, basically you are going to take the coefficient of the linear term. In this case, is the 4. You divide by 2, which will give you the 2, and you square it. That's what you add, right? So you're adding a 4. Now, there was a 13 in there. And then what happens is that we got to subtract the 4 back. Okay? And then now it looks like this. And then, of course, this would actually become a perfect square binomial. So if if you factor this, then you are going to be getting x plus 2 and then quantity square. Okay, and then now what do we have left? We have plus the 9, right? So how do we get the 9? 13 minus 4, and then we get a dx here. Okay, so far so good, right? And then what do we do next? We are going to start making a trig sub. Okay, so I'm just going to do the trig sub on the side so that it doesn't get in the way of the problem, right? So I don't think we need that to be that long. I need to make sure that my solution is beautiful. Okay, anyway, so let's do this. So this x plus 2 right here, okay, we are going to make a substitution. So we are just going to say that x plus 2, okay, is going to be equal to, and as you can see, because that's a plus right here, and we are going to be using tangent, and so it's 3 tangent theta. Okay, and then now you can actually start taking the derivative of this one. So we are going to be getting dx. The derivative of x plus 2 is just 1, so you 1 times dx, so you get the dx here. This one here, we get 3 secant square theta, d theta. Is that okay? Now, we already have a substitution for the x plus 2. We have a substitution for the dx, but we also need a substitution for just the x. Okay, so in this case, we actually want to write that as solve for x. So we get 3 tangent theta minus 2. Okay, so we gotta make that 2. And then now we can start making the substitution in here. So we are going to be getting the integral -6. Okay, now this x is going to be replaced by this expression right here. So we get 3 tangent theta minus 2. Okay, now what about the bottom? The bottom is going to be, well, that x plus 2 is going to be replaced by 3 tangent theta, right? So you get the 3 tangent theta. And then on the outside, there was a square, and then there was a plus 9, right? But that's not done yet. That's not the whole integral. We still have more stuff, right? Don't forget that there is a dx involved in there, right? So that's also really important. 3 secant square theta d theta. Okay. So now looks messy right here, but it's okay. We can just do it step by step and try to simplify it, right? So let's do it step by step. Okay, so we are going to be getting, we can do -6 times the 3, right? So we are going to get -18. And then we still have that 3 tangent theta minus 2 in there. And then there was also the secant square theta, right? D theta. Now, the bottom. For the bottom, it's going to be what? 9 tangent square theta, right? As you can see here. Yeah, so we're going to get 9 tangent square theta plus 9. Okay, so continue with this integral here. We are going to be getting -18. The top part is just going to be the same. So I'm just going to write it quickly. And then what do you get at the bottom? You factor the 9, then you are going to get tangent square theta plus 1. Okay, good news. Yes. First, we can just do some cancellation right here first. Okay, so we can cancel out the 9, so that becomes a 1, so that becomes a 2, right? So you get -2 at the top. Do you see that? Do you see that this tangent square theta plus 1 can actually be rewritten as secant square theta, right? And then there is also a secant square theta in the numerator. So do you see what's going on with them? You can cancel them. That's why I said good news, right? Because you can cancel those things. Yeah, so let's do the canceling here. So this is gone. That one is gone. Isn't it nice? So let's continue. So what are we going to get here? We are going to be getting, well, actually everything in the denominator is cancel, right? So you just get 1 at the bottom. So we don't have a fraction anymore. We are going to just get -2. And then 3 tangent theta minus 2. And then, yeah, so that whole thing, and then d theta here. Okay, so now it becomes a simple integral for us to integrate. So let's do it. So we can do integral. I can actually distribute the -2 first. So it becomes -6 tangent theta plus 4. Okay, easy one to integrate. The antiderivative of tangent is going to be -6 ln of absolute value of secant theta. Okay, and then plus 4 theta. And then there is a constant integration that I'm omitting right now. So let's just focus on this. That's not finished yet because we still need to switch back to the original variable x. So from here, we can actually do that, right? So how do we do that? So from this, from this expression right here, okay, then we can actually solve for tangent. So tangent theta is actually equal to x plus 2 all over 3. Is that okay? Now, from here, we can also get the data to be tangent inverse of x plus 2 over 3. Okay? Okay, so now you may say, what's next? How do we switch back those ones? We can draw a triangle right here. Let's draw a triangle. A right triangle, of course, right? Then you can label your angle right here. This is your angle theta. Okay, so how do you put it opposite over the adjacent? So we get x plus 2 over 3, right? Because tangent theta is equal to x plus 2 over 3, so opposite over adjacent. Using Pythagorean theorem, we can actually just get the square root of, what is that? That's going to be x plus 2 squared plus 9, right? So now we are ready to switch this. So what do we get here? -6 ln of absolute value of secant theta. Secant is what? Hypotenuse over the adjacent. So you're just going to get this radical over the 3. So you're going to get x plus 2 square plus the 9. And then all over the 3. Right? So you get that fraction. And then I do believe that I need a longer bar for the absolute value. Okay, almost done, right? So one more. 4, now what do we get here? This thing, right? For theta is equal to tangent inverse. So we are going to get tangent inverse of x plus 2 over 3. So we got this. And now basically all we need to do is to put down the results for 1, 2, 3, and then 4, right? And then we have the final answer. So now our original integral, which is equal to w, is going to be, let me see, what is that? That's going to be 1/2 x squared minus 5x. ln of x, negative 1 over x, and then all this stuff. And then all this stuff right here. Okay, so let's put them together. So we get what? 1 over x squared minus 5x plus ln of absolute value of x, and then minus 1 over x, and then minus 6 ln of absolute value of the square root of x plus 2 squared plus 9 all over 3 plus 4 tangent inverse, and then x plus 2 over the 3. And then now don't plus c, right? Because we use a c as that's a constant, right? So we're just going to use k as the constant integration. Then we are finished with this problem. So this is the whole problem, as you can see here. That's all, the whole process of doing this integration. It's just tedious work, right? But you actually do run into integral that requires you to use another integration technique. So that's the fun part for this problem. Okay, so that's it for this problem. To help me make math learning available to everyone, please share my videos to others and subscribe to my channel. It will give me support to make more videos. Let's work together to help students and children learn math more easily. Thank you for watching this video.